Okay, so what I was wanting to show you was the sort of the directory structure of what's been added here. And so essentially what we've done is we've added within this tools SAML demo desktop, we've added the functionality that essentially is what would live within Fleet Desktop. And this is the functionality that allows the the device to be identified. So I can pull up that code. That will be desktop main.go.
Oh, and Zach, do you mind giving a quick explanation on why it's important, like how this fits into the flow of the device health?
Yes, right. Essentially, what happens when the user goes to sign on to Okta, they are redirected from Okta to what will be in the future Fleet, but what currently right now is this other server that I'm running because that was how we decided to do it to make it as simple as possible to implement a POC. But this basically everything that's in the SAML demo directory would eventually go into the Fleet server. And so the user in their browser is redirected to the Fleet server where they're given like the email address of who is logging in. And we didn't want to identify the devices just by email address because of this like really problematic UX where what if someone has multiple devices and for example they're not home or even worse they're on vacation and the device that has problems is sitting at home and they have no control over it and we're locking them out even though the device that they're on has it is totally fine. So we really want to know not just who the user is, but we want to know exactly what device they are trying to access the whatever it is they're trying to access an Okta from. And so to do that, we first Okta redirects to Fleet. Fleet then uses JavaScript to make an HTTP request to essentially what would be Fleet Desktop, but again, right now is this separate desktop thing that's running. And that replies with the device identifier, the same identifier that's used here to identify the device to Fleet. And so then the thing that would be the Fleet server now has the device identifier because it's actually JavaScript running on the local system, hitting a server running on the local system to get that device identifier. Now that's sent up to the Fleet server, or in this case, just the server that's sort of pretending to be Fleet. And then that uses the device identifier to look up the device and make the decisions about the compliance. So it might help if we look at the code a little bit, or we could just focus on what the setup looks like.
Up to you. I'm happy to dig into the code a little bit.
Yeah, let's do that a little bit because actually the setup is pretty uh, simple. It's all overall the way it connects is like hard to wrap your mind around, but there's not really that much code going on here. It's all in the how do you get everything to sequence properly. So looking at the desktop portion, essentially all I'm doing is I'm saying bind on localhost 9339, which means, and note that we're not doing 0.0.0.0. So we're not binding on all the interfaces. We're binding just on localhost, which means requests to this server can only be made from this machine, from where there's access to the localhost interface. And so in this case, it's port 9339. There's a comment here that's worth reading more potentially later or right now while I'm talking about the fact that we'll need to probably pick a set of ports that we try using with backups in case people already have things bound on the first port that we try to use. And I'll explain more about why that is later. But basically just we need to make sure that we're bound on a port that the Fleet server can guess, essentially. And we've also configured it with the path where this thing can read the identifier. When it's in the Fleet desktop code, it'll already have that like loaded up into memory because Fleet desktop is using that again for the My Device URL. And then essentially all we do is we start an HTTP server with this identifier endpoint that returns the identifier. And so if we now, we'll need a couple of terminal windows. We cd tools, SAML demo, desktop, go run dot.
So this is starting up that local.
Yes, this is starting the component that would be within Fleet Desktop, but isn't right now because of simplicity. Not sure why that's taking so long, but in the meantime, let's curl up something up. Oh, maybe it's running already and I don't print a message when it starts up. Ah, yes, it's it looks like we don't print a message when it starts up. So actually, I guess it's just running. So if we curl this slash identifier, we get the identifier, which should match the identifier here. So Fleet knows that this host at the moment can be identified by this identifier. This is the one that we rotate though every minute or something, I think. So we can get the identifier by hitting this endpoint. And so now if we look at the SAML demo main, there's more endpoints. In this case, there is a metadata endpoint that's used for like registering with Okta. There's the SSO endpoint that is what Okta redirects to when first trying to do the authentication. After Okta does its initial authentication, then it redirects to Fleet and it will redirect to this SSO endpoint. And if we look at that, what we'll see is it returns HTML that contains JavaScript that goes, okay, let's look at, let's first parse the SAML request from Okta and make sure it's a valid request. And then from the request in the JavaScript that we're going to return, we'll have the email and the full SAML request and the relay state, which is also just a SAML thing. And then what we'll do is effectively hit that endpoint that gets us the identifier. And once we do that, now we have the user's email, we have the original SAML request, and we have the identifier. So then we make a hidden form and submit it with JavaScript, which is a pretty typical pattern for how SAML redirects work. And we're posting to this SSO with identifier endpoint, which is also built in here. So now what we do is, and the reason why we're doing that is because remember, this is happening. It's a little confusing here because right now this server that we're looking at is running on my machine, but normally this server would be the Fleet server, so it would not be running on the machine. So the reason why we have to do all of this and then post to another endpoint is that this is all happening on the user's machine, and we need to get that identifier up to the server. So then we post back up to the server to another endpoint where we're now getting the SAML request again and parsing the SAML request. And then we're getting that identifier from Fleet. And then this is where we do our check. And in this case, if you look at this, you'll see that because we're not in the Fleet server, we're actually making an HTTP request out to the Fleet server. This is where I think once the code is integrated into the Fleet server, there's no HTTP request here, but if effectively this check by identifier can just become do whatever the check is that the user has configured or that Fleet decides is the default check to do.
And I'm trying to make sense of like where the user, where they are in the journey at this point. Have they entered their credentials into Okta when we do that check?
Yes.
Or yes. So
I
they've
can
entered their
show you on
credentials.
I can show you on Loom.
Yeah, that's what it would be awesome to pull that up side by side.
So they've okay, so they're in Okta signing in. And oh, hold on, I'm just gonna mute this. So they're in Okta signing in. They verify with their password. And once they do that, Okta says you need to verify with Fleet. So you hit verify here, and this redirects to localhost 9337 is like my fake Fleet server. It's this server that we're looking at. And a bunch of stuff happened here very quickly. So you can see here, Okta redirected to localhost 9337/SSO. So that's that first step. So here is where JavaScript is running the request to localhost 9339 to get the identifier in the browser. And then it's going to redirect to the SSO with identifier endpoint, where now that it has the identifier, it's doing this check. And in this case, the check fails. So we render our failure image, which again, probably won't be an image in the future, but we did that again for ease.
Oh, I see. Okay, so the check fails. Like we couldn't find the identifier or something like that. And then
No, it's not because we couldn't find the identifier. We did find the identifier, but there was a policy failing.
Got it.
So now I'll scroll down here and I'll say, well, look at my device, see what the policies are. And again, this is where a much better UX would show actually which policies are failing right here. And the refetch button would be right here. And then there would be a button that says like, bring me back to Okta to try again. But right now, because we haven't actually made the changes in the Fleet server and wanted to do it pre-MVP, we did this. So here I'm remediating the policy issue. It's just this silly policy, but the one that's easy to flip on and off. And I'm doing the refetch to make sure that the policy is now passing. Again, I think ideally all of this happens still on the same page that you saw when you first got the failure. And so now this is all good. So now I'm going to go back and try again. And I believe there are ways to make it not ask for the password every time, but I was having a hard time figuring out how to get Okta to do that successfully. So not totally sure.
In the identifier
okay,
check,
so this time.
Oh,
go ahead.
I was going to say if the identifier check, if we don't get an identifier, we just today in the POC, we're just letting the user through. Is that right?
If we don't get an identifier, then in the POC, let's see. If we don't get an identifier in the POC, I'm not even sure we're handling that case.
I mean, yeah, I'm curious.
I think that probably if we don't get an identifier, the JavaScript is going to fail here.
Got it.
We're going to or we're going to get a empty value here. And then when we come here to the check by identifier, then this API request is going to fail and we're going to return an error. So then we're going to return the page like you're failing policies.
Makes sense. Yeah.
Even though actually we don't really know that they're failing policies. This is just the only error state that we've developed so far.
Right. And in the real like I'm trying to think of a real world scenario. This would be like if you're logging in to Okta from your phone, we would run into this case, right? And then I'm curious
Yes,
for
and
folks
something that you
watching,
can
like
do is if you're
what
logging
they would
into Okta
expect.
from a phone, you can tell Okta to recognize when it's a phone logging in and have it take the user through use a different authentication policy as they call it, so that they wouldn't have to go through Fleet, for example.
I see. Gotcha. Okay.
Um, or we could decide that, yeah, if we don't find an identifier, we don't allow them. But I would think that probably the ideal thing is if you don't find an identifier, then actually we're giving the user instructions for this is how you need to get your device enrolled.
Mm.
And in
Oh, right.
particular, if this is an organization that's using MDM, this is actually a great opportunity to be like, hey, if you were enrolled in MDM, you'd have Fleet D already. So actually, we're realizing that now you're trying to access internal resources with a device that's not even MDM enrolled. And we have an opportunity to right there have the user get their device MDM enrolled.
Yeah, makes sense. Or if they're not
So it's a
like,
really good it's a really good checkpoint, and it's I think a differentiator from something like what Collide One Password do, which is all sort of user-based remediation. Like we and not they can't they don't do MDM, so they can't be like, oh, you're not enrolled in MDM. Like here's how you fix it right now. They can be like, here's the link out to your MDM. Go figure it out or something. But we can walk the user right through the process of getting enrolled into MDM, which I think is special.
yeah, makes sense. Or like for fiddling with the agent too. Like we had someone at Fleet who was just trying to see if they could disable the Fleet D agent. If that was
Yep.
just the first check,
Yep.
then you'd have to resolve it. That's a good
Yep.
one.
Yeah. So back to this. This is the with MFA version. So we come back to Okta after this is resolved, and we do our initial. Oh, sorry, this isn't playing. We do our initial login again, and we do our verify with Fleet, and this time it all goes very quickly again. But you see that uh, it's at localhost 9337/SSO, and then it's at SSO with identifier. These are again, this would be the hitting the Fleet server with this, and now the Fleet server is like, okay, everything's fine. So now this is where we do the weird thing where we redirect instead of returning back to Okta that the initial request was valid, where where we were acting as an identity provider to Okta. Now we act as a service provider and we ask Okta to do another authentication. And this is the thing that allows you to do Okta Verify. So we redirect back to Okta as though we are a service provider. I don't know why, and I think there's probably a configuration that would allow you to make it so they don't have to put their username in again, which seems very silly because Okta already knows, or should already know, I think. But anyway, you put the username in, and now the authentication policy says do Okta Verify, do the push notification on Okta Verify. So now that happens, and I had just tapped on my phone the verify button from the push notification, and then Okta redirects back to yet another URL. This is the URL where our sort of second step is succeeding. So we hear back from Okta that that this Okta verify succeeded, or this could be the YubiKey or whatever it is that you want to be doing here. When it returns back from this, now we can return back to Okta that everything is all good with the initial identity provider based check that they set up with us.
Got it.
And
So
in the code, you can see that as as this. And we would have had to store in the database or Redis some information about the in-progress authentication so that when Okta comes back to us with that, like Okta verify the MFA is good, then we can look up like, okay, what was the initial assertion, SAML assertion, or that we were trying to answer to. And we also double check that like the name of the first Okta authentication matches the name of the second Okta, or the email that would be really matches that, which just seems like a good, important security step. And then if that all works, then we make the SAML assertion and write the response, which is again going to be sort of like this. It's going to be another one of these post forms that's automatically submitted with JavaScript, and you don't really see it here because it all goes by so quickly. But you see it in the you saw the SAML ACS there very briefly.
Yeah. So just and I know we just hit time too. At like a high level, for if someone was trying to set up this POC environment, you've got like your Fleet server running. You have that local server to send the host identifier, to request the host identifier from, and then you also have this that will be the Fleet server, this like third SAML server running as well.
But those are both built in to the same server here. You can see this SSO is that initial step when Okta first sends to us. And then this SSO with identifier is that second step before we send back to Okta. But this SSO with identifier is the thing that redirects back to Okta.
Okay. Okay.
And
So as like a Fleet contributor, you just have to start up the Fleet server, and then these endpoints.
You have to start up this server. So,
Okay.
and this one is started very much the same as this desktop thing, but we go to tools/SAML demo, and we go run.
Oh, you don't have to start up the Fleet server at all.
Well, in this case, you might want to start up the Fleet server. In this case, something happened with the dependency updates that I did here with this merge, looks like. So I'll back out that merge. That was just to make it easier for you to see the directory tree. But the answer is you don't have to be running a local Fleet server. In this case, I configured it to use dog food.
Ah, I see. Makes sense.
And so that's what allows me to do it with my actual device enrolled. Well, I could unenroll my device from dog food and then enroll it into my local server and do it this way. But then you would also have to set up ngrok or something that would, or let's see, or would you? No, maybe you wouldn't, because the request that needs to be made to there could just be a localhost request. And as long as you're doing it from the computer you're developing it on, then it works fine. Should work fine.
Okay.
But yeah, I did it with dog food because that just is there, already has data in it, and it seemed easier.
Makes sense. Yeah, thanks for the tour.
Yeah, it's really cool, Zach. And of course, all of this gets moved into Fleet server and Fleet desktop when we're ready to build it into the core product, right?
Yes, that should, yeah, and maybe it gets rewritten, some of it, like, sure. But the general concept, yes.
But yeah, the concept all works. Shows the flow, which is kind of the difficult part of how do we handle all these redirects and wire this thing together.
Yeah.
So that's really helpful, and I mean, obviously there'll be some work building it in, but I don't think it'll be a huge lift to build into the core product with all of the work that you've put in already.
Yeah, I mean, hopefully not. And you know, as you'll see when you look at this code, it's really only a few hundred lines of code. Almost all the work was just figuring out like how the heck do you sequence all of this?
Right.
But when we go to build, you know, I think there's actually more of the development work might be the like, well, what do we show the user when they fail the policies? How do we give them a good experience to like see the remediation instructions and be able to do refetches? And how do we let the admins configure which policies affect this and all of that kind of stuff, like has the potential
Yeah.
to be way more work. But we can also do, real MVP versions of those to get it in the product and iterate.
Right.
But
And
I
then,
think that
yeah.
ultimately those will be much more work than sort of this core of the Okta dance.
Right. Yeah. Yeah. It's not necessarily complicated. It's just, well, the code's not complicated. The process is, and wiring it all together and what you need to get and what
Yeah.
you need to send. And then, of course, the sending it over hidden inputs and things like that, just getting all the redirects right.
Yeah. And the experience is pretty raw today. To
Right.
Zach's
Yeah.
point,
So
yeah.
like it's really the biggest challenge is a UX challenge. And no, I think when y'all are designing this, creating a workflow diagram like you had for the calendar updates would be really helpful because of all the kind of different ways that this can branch and redirect.
Makes sense.
Yeah.
Yeah.